Welcome back to AI Talks with Chris and Nita. Today, we're going to be doing a deep dive into the world of probabilistic clustering.
Oh, fun.
You sent me some research on this.
I did, yeah.
And it's a head scratcher,
It is.
but very, very interesting.
Yeah.
So probabilistic clustering and machine learning.
Yeah.
Imagine like grouping stars based on their characteristics.
Right.
That's kind of what these algorithms do with data, right?
Yeah, that's a great way to think about it. I mean, at a high level, what we're trying to do is group similar things together.
Yep.
But what makes probabilistic clustering special is that we go a little bit deeper and we say, well, what's the probability distribution that might have generated this data?
Okay.
So instead of just saying, these stars look similar, let's put them together.
Right.
We're actually saying, well, maybe these stars were generated from the same process.
Okay.
Kind of like, if you have a bowl of fruit and you have, apples and oranges, instead of just saying, oh, these apples are red and these oranges are orange,
Yeah.
we're saying, well, maybe these apples all came from the same apple tree
Uh-huh.
and these oranges all came from the same orange tree.
Right. So instead of looking at just the data points, we're looking at how were those data points even created.
Exactly. So it's about the underlying process, not just the superficial features.
Gotcha. Now, within this probabilistic clustering world, there's the Gaussian mixture model, or GMM.
Mm-hmm.
So why is this one a popular one to use?
Well, the Gaussian mixture model, or GMM, is super popular because it's very versatile. What it does is it assumes that your data is generated from a mix of Gaussian distributions.
Go ahead.
And the Gaussian distribution, as you may remember from your statistics class, is that bell-shaped curve.
Right.
That describes so many things in nature, right? Like the heights of people in a population.
Right. Yeah, like you have some people that are really short, some that are really tall.
Exactly.
And the majority are somewhere in the middle.
Most people are somewhere in the middle,
Yeah.
right? And that's what the Gaussian distribution captures beautifully.
Okay.
And what's really cool about GMMs is that they can handle clusters that overlap, and they can account for how spread out the data is within each cluster.
So it can deal with those like fuzzy boundaries, not just like clear-cut categories.
Exactly. So, it can handle situations where, the boundaries between clusters are not very clear.
Could you give me an example of that, like how that would apply?
Sure. So imagine, for example, that you have, a medical image.
Okay.
And you're trying to identify, let's say, a tumor.
Okay.
Right. So a GMM can help you distinguish the tumor from the surrounding healthy tissue, even if the boundaries are a bit blurry.
Oh, wow. Okay.
Right. So it can account for those nuanced differences.
Okay, that's really neat.
Yeah.
Now, I imagine with all this power, there must be some downsides to using GMMs.
Yeah, of course. Every model has its limitations, right? So one thing with GMMs is that they can be a bit sensitive to the starting parameters.
Okay.
So, for example, the number of clusters that you initially assume,
Right.
you have to kind of tell the algorithm how many clusters you think there are to start with.
So you need to have a pretty good idea before you even get started.
Yeah, kind of. And if you get that wrong,
Okay.
then the algorithm might not converge to the right solution.
Gotcha.
So it's a bit like, baking a cake. If you
Sure.
get the ingredients wrong at the start,
Right.
the cake won't turn out right.
Gotcha. So it's, being really careful about the initial assumptions. Are there any other limitations that we should be aware of?
Yeah, so another thing is that GMMs can become computationally expensive when you're dealing with very large data sets,
Okay.
especially if the data has a lot of features or dimensions.
Gotcha.
Right. So it's like, trying to herd 1,000 cats.
Yeah.
It can get a bit chaotic
Right.
and resource intensive.
So it's a powerful sports car that, it's got, you need a skilled driver,
Right.
and it might drink a lot of fuel.
Exactly.
Awesome. Well, it's been amazing learning about probabilistic clustering and GMMs. Any final thoughts to leave our listeners with?
Absolutely. So, GMMs are just one piece of the probabilistic clustering puzzle. There are many other fascinating methods out there, each with their strengths and weaknesses. So the key is to really understand the problem you're trying to solve.
Okay.
And choose the method that best fits the data
Okay.
and your goals. And of course, always be mindful of those limitations we discussed.
Awesome. Thank you so much.
Yeah.
This has been a really, really fun deep dive. And listeners, here's a thought for you to ponder. How might understanding the underlying probability distributions of data change the way we approach problem solving in different fields? Until next time.